Welcome to another video on digital electronics. In this video, we'll be seeing module 6 programmable devices. So, programmable logic device or PLD, it is an electronic component which is used to build reconfigurable digital circuits. Now, if you remember combinational circuits which we had made using gates, say for example something like this. If I make this circuit once, I cannot modify or I cannot change anything in this circuit, right? But if I have to add multiple functions to this circuit, then I'll have to recreate this entire circuit. So rather than doing it, I should have a reconfigurable device which, depending on my requirement, I can reconfigure it and get the functions that I require, right? Because what is eventually a digital circuit? It is nothing but a function of some variable, say a, b, c, which is given as summation, having couple of min terms. This is a function, right? So I should have a device in which I can reconfigure this. So function of a PLD is undefined at the time of manufacturing. So there is a chip which is made, which is not defined any function. So it is undefined. It is like a piece of a cloth which you get in the manufacturing, and depending on my requirement, I can make it as a full shirt or a half shirt or anything like that. So similarly, from this chip I can design any function that I require. So PLDs are broadly classified into increasing order of complexities: simple programmable logic devices, SPLDs; programmable array logic, PAL; programmable logic array, PLA; generic arrays; complex programmable logic device, CPLDs; and field programmable gate arrays, FPGAs. So these are various types of it. We are seeing the very first one, which is called as PROM. PROM is not for you to solve but to understand and get the concept of what is PROM, and depending on that we'll do a PLA and a PAL design. So PROM has a fixed AND gate and a programmable OR gate, right? So this is your fixed AND gate and you have programmable OR gates. First of all, why this AND and OR is required? If you write any function, example f1, this function say is given as a bar bc. It is a 3 variable function plus abc plus a b bar c. This is a function. Similarly, I can have some other function of 3 variables, say a bar b bar c bar plus a b c bar plus a bar b bar c, right? I am having two functions. I can have multiple functions. So when you look at this function, what you have, this is called as a min term. This is also a min term. This is also a min term. To implement this using logic gates, what kind of gates are required? First, you will require an AND gate to do a bar b c. So I'll have an AND gate with 3 inputs having a bar b c. Then again I'll have one more AND gate with a b c, and these two, and one more AND gate with a b bar c, and these 3 inputs will go to one OR gate. This is how the implementation is, right? And hence I require AND gates and OR gates. So this is the concept of having a fixed AND gate and a programmable OR gate. What is a fixed AND gate? Let us discuss what is fixed AND gate. Okay, so I had my two functions here. Now fixed AND gate will have min terms generated. What does an AND do? Multiply, right? Because it is fixed and I am having 3 inputs, 2 raised to 3 is equal to 8. So how many min terms are generated? 8 min terms are generated from M0 to M7. Do you have any other combinations of min terms possible? No. You will have only 8 min terms. So, and hence you have a fixed AND array. AND array means how many AND gates will be used here? 8 AND gates, which will take these 3 inputs and generate this 8 min terms. Once these min terms are generated, to create any function f1 and f2, I require to just add these combinations of min terms. So for example, I have already written functions here, so I will erase this now. I have wx as functions having minterm m0, m1, m3, m7, and x as m2, m4, m6 and m7. So I can also have an m4 also. So any function is a combination of minterms, right? Okay. So when I have to write down w, this is a programmable OR. This is a programmable OR. So I have the flexibility to choose my minterms depending on the function. So for w, I have m0. So I'll make a connection here. I have m1, then I have m3, and then I have m7. Which means when I do these connections, which means what? In this OR gate, I have these 4 minterms going, which will eventually give me this entire equation as w. Similarly, say for x I have m2, I have m4, I have m6, and I have m7. So this will create an x for me. Since this is programmable, I can do any combinations of the minterm, right? That is up to me. And output, so depending on the chip's capacity, say it is a 3 input, 8 minterms and 4 output. 3 input, 8 minterms, also called as product terms, and 4 output. So this will give me maximum 4 functions. I can manipulate the functions using a programmable OR, and I can get 4 output functions using this kind of a chip, which will do 4 different jobs for me. So this is your programmable ROM. It is also having some variations, which is called as EEPROM, erasable programmable read-only memory. EEPROM is electrically erasable programmable. I can electrically erase this. I can erase this part, and I can redo the connections, right? Then you have UV EEPROM. I can erase this using ultraviolet rays. So UV, ultraviolet erasable PROM. Then you have electrically alterable PROMs, which are also called as flash memories. These flash memories are nothing but your pen drives which we use. That is your EEPROM. So I hope the concept of PROM is clear. If you understand this, then understanding PLA and PAL becomes very, very simple. Since this is a fixed AND array, I am again repeating, all the minterms are generated here. And since this is programmable OR, I have the flexibility to choose my minterms in a given function. So I can have any kind of a minterm here. This I have to program depending on my requirement of the function. This fixed will be generated by the AND array depending on the 3 inputs. If you had 4 inputs here, then you will have 16 minterms here, because 2 raised to 4 is 16, right? So you have 16 minterms here. I hope the concept is clear. In next lecture, we will see PLA. I'll stop the video here. Thank you for watching.